capital M. Molality is a lowercase m, and it's one letter difference. So when we're talking about these solutions, we're talking about a molar solution or a molal solution. So molarity is moles of solute divided by liters of solution. Molality is moles of solute divided by kilograms of solvent. So the only thing that's different besides capital and lowercase is going to be your dividend, your denominator, what you're dividing your moles by. So let's look at these in more detail. So here's our example for our percent by mass or volume. Remember, they're going to be done the same way. So in this example, we are trying to maintain the sodium chloride concentration of ocean water. So an aquarium has to have 3.6 grams of sodium chloride per 100 grams of water. So what's the percent by mass of the sodium chloride in their solution for their tanks? Let's write down what we know. We know that the mass of our solute is 3.6 grams of sodium chloride. We know the mass of our solvent is 100 grams of water. What we're trying to find is the percent by mass. As a reminder, here's your equation for percent by mass. So we're looking for the mass of our solute divided by our mass of our solution. Our solution is equal to the combination of our solute and our solvent. So we're going to have to take our number for our solute and the number for our solvent and add those together to get the total mass of our solution. So we know our solute is 3.6 grams. When we add 3.6 for our solute to the 100 grams of our solvent, we get a total mass of solution of 103.6 grams. So we take those numbers, divide them, and then multiply them by 100 to get our final answer, which is that we need a 3.5% by mass sodium chloride to be most similar to ocean water. Our second way, and the most common way of talking about the concentration of a solution, is by talking about its molarity. We're getting ready to start acids and bases. So molarity is going to definitely come into effect there. As a reminder, here's our equation up here. We're going to take our moles of solute divided by liters of solution. So those are what we're kind of looking for when we're reading our problem. So we have a 100.5 milliliter intravenous or IV solution contains 5.10 grams of glucose. What is the molarity of this solution? And it gives you the molar mass of glucose. So we're going to write down what we know. We need moles of solute. I have grams of solute. So to go from moles to grams to moles, I'm going to take grams, divide by my molar mass to get moles. So that's part one that I need. I also need liters of solution, and I was given milliliters. So remember, there are 1,000 milliliters for every 1 liter. So I'm going to take my quantity in milliliters, divide it by 1,000 to get that same quantity in liters. Now I'm going to plug those numbers into my equation and get my final answer of 0.282 molar. So the molarity of this solution is 0.282 molar. Your unit is a capital M. For our molality example, again, here's our equation. So remember, the only difference between molarity and molality, besides an uppercase and lowercase m and this L and the R, is our number that we're going to divide the moles by. You're really not going to use molality too often. That's why we're not really going to spend a ton of time on it. Really, you would only use it in a laboratory setting. So in the lab, a student adds 4.5 grams of sodium chloride to 100 grams of water. Calculate the molality of the solution, and it gives you its molar mass. So kind of the same thing we had to do before. We're given grams of solute, but we need moles. So we have to divide by the molar mass. To go from grams to moles, you divide by molar mass. And we were given grams of solvent. we want kilograms of solvent. So just like milli, kilo means 1,000. So there are 1,000 grams in every 1 kilogram. So I had to divide by 1,000 to go from grams to kilograms. Now we're going to plug it into our equation to get our final answer. With molarity, even though it's moles per liter, it's so common that we report the unit as a capital M. With molality, you can do it either way. So you can either report your answer in moles per kilogram, or you can use a lowercase m. To avoid confusion and to agree more with our SI units, you will more commonly see now 0.77 moles per kilogram. That's to help avoid any confusion.